And good morning. I think I've got everything all queued up here. Let's just find out. Make sure I got audio. Yep, I do. Okay, we're good there. Awesome. Okay. Still trying to adjust this new setup with my Sony camera. Love the quality. It looks great. I think I've got the lighting a little bit better so that I don't kind of look natural. So hopefully everything's good there. Great camera, love it. Definitely took a lot of playing around to get used to how it actually works. So, okay, so let's see here. Yesterday we were doing the great refactor. We did the separation, so we got everything working with. Basically taking all the turn handling, putting it into the turn manager, pulling that out from underneath the combat manager, taking out the game board and the combat manager's turn management stuff that it was doing, putting it back into the turn manager. We do have a couple issues with the monsters not waiting their turn. I think that's going to be a pretty simple fix when we get into it. I think all I did was I messed up and left off in a wait, but we'll get into that. I'm trying to think here. There was something else. That was the big thing that we're doing. We'll run through a quick play session here at the beginning just to see where we're at after yesterday. I spent the morning trying to work out the breadth first search to try to get that working. I got it working, but my monsters were still stacking on top of each other. So the entire point of this was to stop them from stacking on top of each other. But they were actually looking for other cells around the player, not just going to the absolute first one. So I think I made some progress on that in my test bench. So let's see when I bring it into the production environment and see if that actually works. If we get that working, then we're going to work on the targeting system. And then, so hopefully today we'll have some good stuff. The targeting system I haven't really messed with. I just kind of dumped some random ideas and how that's going to work for the targeting state. But if I may just skip forward and go straight to the buff system, get that implemented because again, I've done that one before, and it's just a dictionary and processing the dictionary, so it should be pretty straightforward. But yeah, that's our goal today. We're gonna do the monster refactor that we talked about yesterday, just trying to fix it so the monsters will use AP points, and that so the monsters will properly end their turn and wait to end their turn. Because again, we have the basically a race condition, the async problem where the monster's not fully done its turn yet, but it's already moved on to the next player, and then the monster takes its turn and does the action. And sometimes we have it so the monster's action is being attributed to the player instead because we're all working off the current turn node, and if the current turn node is the player, then it's attacking. Yeah, so we'll get that fixed. So I think that's the big thing is we'll get that refactor first. That shouldn't take very long. Then we're going to dive into the breadth first searching. And then the goal is to then hit the targeting system once we get that working. So let's see here. We need to hit over to Godot. We don't want to go back to our splash screen like we did last time. So let me just open up. Let's open up the project here, and then we'll come back over here. We'll look at our tracker. So let's see. Today we are not working on that yet. We're still working on the other stuff. Okay, so I'm just going to start a generic timer for Dungeon Fire tiles. Let's see. Monster, AP use, BFS, and targeting. Okay, that's what we're gonna work on today. Okay. So let's go back in here. Let's do a real quick run to see where we are with this. And then there's some of that stuff I need to clean up. Okay, so we've got, I think our attack is broken right now. Yeah, that's going to be broken because we did the ability thing. And yeah, so we're passing ability when we don't need to pass the ability with an attack. Yeah, it's... a mess. But anyway, let's see here. So we're at moving here. We got this. Let's see if I can get the monsters to accidentally take extra turns. Yep, see, this is what's happening is they're moving before they finish their turn, and then watch this. This will be, yeah, he now attacked his comrades. So it's like they took over psychic control of them. But I think that's going to be a pretty easy fix. I think all we need to do is go into our melee attack. Here we go. And yeah, see, I took this out. So I need the await action complete. And then I think I want to do a fix on this as well. Let me think how I want to do this. Because remember, we're doing our call down signal up. So what I want to try to do is I want to try to signal that the monster wants to attack, because we're not going to be able to get a call to the game board because this is a logic script and not an actual item, a node on the board. Sentient enemies is a nice bug. Enemies that don't wait and take over your brain. They're like the what's that in D&D? The intellect devourers. They'll just go in and eat your brain and take its place. Okay, let's see here. So let's go. I'm gonna take this out because I'm gonna refactor this because we don't want to do, call basically the what's grandparent at this point, the parent of the parent, grandparent. Yeah. So we don't want to do this. Let's take this out and let's do if there's a target. So just in case there's not a target, we're trying to add in some catch stuff for us to make sure that if for some reason we end up in a code state that we don't want to be in, then we want to make sure we don't end up there and execute the code. So let's do a monster. Let's emit a signal. Yeah, let's do that because we need the signal up to the game board. So let's call it attack. Let's do attack requested. REQESD. Okay. Attack requested dot emit. And we're going to have to define this. And we're going to need to send the target, like who we're going to attack. Okay. And then once we do that, this is where we need to await the action complete. Yeah, I think that's all we need to do there. Now we just need to connect into this signal. Whoops. What am I doing? There we go. Thought I pasted something. What were we calling before? I'm just going to copy this. What was the parent thing? Target selected. Okay, so we just need to connect into that signal for this monster attack requested and into target selected in the game board. Okay. Okay, so let's save that. Okay, game board. So we need to connect into a signal. Where are we doing that? When we do the actor? Where are we? Update active? Nope. Actor move. Get all actors. Actor spawn. Here we go. This is what we want here. Okay. So we register the actor. And then we say if actor is monster. Okay. Then what we need to do is we need to underscore actor attack requested.connect, and then we're going to send it to target selected like that. Okay. So that, I believe, should be all that we need to do that. I'm trying to think if we need something else. Or should we wait for... No, you know what? No, let's not do this here. Because this is on spawn. And what's going to happen... Let's not do it on spawn. Let's do it on when we activate the player or the monster. Actor, don't we have an activate? Oh, we had an activate in here somewhere. Update active. Here we go. Here we go. We're in monsters. Okay. So we don't need this because we already know that it's a monster. And then we're sending in the actor here. So we just do actor attack requested, connect to target selected. Okay. So then we'll turn it in here and we'll connect to that signal. I'm just trying to think about where we need to deactivate that signal. Oh, I think that should be fine for right now. So we got this signal. So then we call the target selected. And then the target selected, I believe, this one, come down here, we await. I think, I don't know if we need anything else. Let me think here. There's monster. There's got to be. Where's our advanced? Do we still use advanced turn, or do we get rid of that? I think we got rid of advanced turn. Update active. Yeah, that's all in turn manager now, I believe. Turn manager. Advanced turn. Here it is. Yeah. So that is here. If this turn ended, current turn node, we move to the next one. Yeah, I think that's all we need. Okay, let's try this. Let's see. Error. Attack requested. Character body 2D orc. Where'd we add? Did we add the signal? Oh, you know what? We didn't add the signal to monster. Signal attack requested, and then we're gonna send. That's gonna send a actor or node. Let's do node, just in case, like in the future, we in case we want to do like make it so that they can attack doors or something along those lines. So, okay, let's try that. Okay, so let's move here. Let's make sure that we wait our turns. I'll just move him over here. We'll move him out of the way. Where you want to hide, wizard? There you go. Okay, roll, wait, attack. And we're not moving to the next turn. Okay, so we moved, we attacked. We did not advance to the next turn because it looks like he did not run out of. Oh, we still got to adjust the things to cost money. Okay, so at least now we've bypassed the the problem with them moving ahead when they weren't supposed to. Okay, so let's go back over here. Let's go to, we have our monster GD. We add the signal attack requested, so we did that. Okay, so we got that. What we need is these for the decision engine, and I think we called those monster logic. What do we call it? Logic step. That's what we called it. Okay. So in logic step, we're going to need to set up a way to subtract the AP cost. So we need an export var AP. What do we call it for the player? AP something here. Let me just, oh, excuse me for 1 second. That is, I have no idea what that is, so we'll just let it go to voicemail. My son is slightly under the weather, so I'm paying attention just in case school calls. Or normally I'd just totally mute it. let's see here. So we want to add in an AP cost. I think it's just what we call it for our players. Actor, no, ability. There we go. We called it, yeah, just AP cost. Okay, so let's just use this again. AP cost equals 1. Okay. So by default, these are all going to cost 1. I think, do we need to do anything else? I don't think we do. We may have to check. Okay. Unfortunately, that was about my other son. Do you have a system in place for AP distribution, cost per move? That's what we're just adding in right now because our logic, if we come down here into our monster logic, we have a move melee attack here. Now we have an AP cost for it. For move, we now have an AP cost for it. So that's what I just added in. So that should, I hope, fix that. Let's see here. So it started off attacking, but it did not go anywhere. Okay. Let's try this again. Move, attack, end turn. Did not end turn. Okay, so the move did not subtract properly. Okay. Let me see something here. One moment. What was I? Sorry, getting that phone call is distracting me slightly. Okay, so we decoupled that. We put the away. I'm just looking through my notes that I had to prep for the session. Decision engine. We need to subtract it. That's right. Okay, so we need to come in here and actually subtract our cost. Okay, so in the decision engine, we need to come in to find the valid step. Right here, step in logic, step requirements, monster players equals true. Return the step. And then we also need to have, so we send the step requirements equals true, we return the step. We need to validate the AP cost in case it's like an AP cost 2. So I think we're going to have to rewrite this. Let me think how we want to do this. If step dot AP cost is less than or equal to, do we have a monster right now? Yeah, I think we do. Monster reference dot, oops. There we go, step. Let's put a space in there so it doesn't keep running into it. Monster dot, do we call it action points? Action AP. What would we call these again? I think they're called I thought it was called action points. Right? Action. Yeah, action points. Okay. So if the step AP cost is less than or equal to the monster's current action points, and the step requirements are true, then we can return the step. Okay, so that will check it to make sure that we can afford it. And then in here, when we execute it, now we have to actually subtract it. So the question is, do we need another safety check, or do we just subtract it right off? I'm trying to think about that one. Now, I think what we'll do, because we find the valid step here, and then if the next step is null, we break. Otherwise, we execute the step. So I think in here, because we're going to replace this function. I thought about this before. I didn't want to use a while loop, but I think we're going to. But I need to okay. Unfortunately, look, I just got another message. I'm going to step away for one moment and I will be back. Okay, sorry about that. My son is misbehaving at summer camp, so I had to arrange with my wife who was going to go pick him up. So that's the joys of being a parent. Apparently, he was roughhousing with the other boys, and physical altercations are against policy. So if you have young children, I feel your pain. Okay. So where were we here? We were making sure that we subtracted the action points uh, after we run the logic. Okay, so here's our run logic. We're going to change this to. Oh. Okay. I was wondering why they called me and not my wife. Apparently, my wife's cell phone isn't working. Okay. Let's see here. So I think I'm just gonna replace most of this. So we're gonna call run logic. Monster is gonna get the parent. That's fine. We're gonna reset them to their max action points. We're gonna go through. We're gonna replace this for loop. This is gonna become a while loop. So let's change this into a while. And then we're gonna do while monster action points are greater than 0, then we're gonna execute the loop. Yeah, I this is what I'm gonna do. I want to do safety. I talked about it last stream. I don't like using while loops because then you can get stuck in infinite thing. So I'm gonna do a max iterations. Is that iterations? Is that how you spell iterations? I don't remember. Sure. And we'll just set something. 10 is going to be way too high. But we'll do this. While monster action points is greater than 0 and max iterations. Do I just want to subtract from it? No, let's have a separate one. Let's do an iterations is less than max iterations. So then we can kind of keep them separate. Max iterations. There we go. So then we need another variable here. We're going to do var oops. I hit iterations. Why did I add an N to iterations? Iterations? Iterations and equals 0. So it's going to start at 0. And then when we're in the while loop, we'll just increase it. This will just give us an extra layer of protection. In case somehow we get stuck in an infinite loop, we don't crash our game, we'll kick it out after he hits 10. We should never get to 10. Most of our monsters are going to have 2. There may be some times where like a boss or something like that might have like 4, 3 or 4 or something like that. But we should never get to 10. If we get there, we've definitely done something wrong and gotten in big trouble. Okay, so the very first thing we want to do then is we want to increase our iterations here. Plus equals 1, just to make sure we're going through and we can get out of that loop if need be. And then we need game manager, game running. Okay, yeah, that was our making sure we're only doing this if the game's running. That's another safety check. We got plenty of safety checks in here. Okay, and then we're gonna find all players. We're gonna figure out what our valid next step is. If the next step is null, we're gonna just break out of the while loop. And then here, let's add in one more safety check. Let's do a previous action points, and then we're gonna make that an int. So that's gonna be equal to the monster action points. ACT action points. I don't know why that's not. Oh, you know what? We never defined monster as a actor. That's why it's not coming up. Oh, where'd we define monster here? Here. Oh, we defined that as a node 2D. Let's define that as an actor. There we go. Now that should, when we do this now, we should be getting action. Yeah, there we go. Okay, that fixes that. Okay, so we're going to do the previous action points, and what we'll do is we're going to compare to before and after to see, make sure that our math worked right. We didn't mess up some loop there. Okay, so we've got that. We're going to check. We're going to await the execute step. And then this can wait. That's just our pause that we have in there. But let's add in our safeguard here so we can say if monster action points, okay, is greater than or equal to the previous action points, then we know we've hit a problem because we should have subtracted the action point somewhere. So we'll just print an error here. Print error. I don't know. Yeah, we'll just say step didn't spend AP. There we go. Okay, so then we have the error, and then we can just manually do it just in case. Where we'll do monster.action points minus equals 1. So again, this is just another level of, hey, we didn't spend an action point for that. We're going to force it to remove. Do we want to do that? I don't think we're going to give any monsters a free action. We might do that with players at some point. For right now, we're just going to leave this in because, again, if you saw my previous stream, I'm very paranoid about while loops at work when I use them professionally. I can't tell you how many times I've crashed a script due to a while loop not behaving the proper way. I mean, not being coded the proper way by me, but so I'm usually very hesitant to use the while loop. But okay, so we're going to check out, we're going to add in the action points -1 so we can force it to reduce it. Do we need another? I don't think we need anything else because that's going to pause before the next loop. And then we won't need this because we're going to subtract. The while loop should do all that. Oh no, you know what? We should leave that in because if we break out like here and we haven't spent all of our action points, then we're going to have action points left and it won't end the monster's turn. So we do want to set that just in case as another safety step to make sure that that happens. I think that should be everything we need here for that. But we still need to spend the action point somewhere. So it looks like, let me think about here in this. I think we're going to do this in the execute step. So I think here, this is another safety check to make sure we're not trying to execute something null. We're going to step await the execute. So right here before the await, I want to use the spend the action point. And I'm trying to think now because we don't have, we have the step. The step's going to have the AP cost. So if we do this, we do monster action points minus equals step AP cost. There we go. Boom. So that should be good there. Sorry. Sorry, just again, the wife's cell phone's not working, so she can't call summer camp to say she's on her way. Okay, so we got that. We're going to spend it here. So that should all work. Let's see here. So if we move, let's put the wizard over here. Spend. Not enough AP. Okay, so it's spending, but now we just need to make sure we're ending our turn properly. Okay, so we're spending. We're getting out of the while loop, I believe. Because did we get the turn is over? We did not get the turn is over. Yeah, here we go. Melee attacking. Targeting the barbarian. Did this. We got an error, not enough AP. Which was... Oh, wait. Are we spending the AP in the game board? I may have done... Where are we? Targeted. Target selected. Monsters. Connected. Use action point right here. Okay. So we're trying to subtract it there. Okay, so okay, so we don't need to. Okay, so maybe we don't need to call that over here. Where's our execute? Execute. We may not need this. Let me just take that out and let's just try it. It's 1, 2. And okay, there we go. Yeah, so we already have the logic in place for the players to subtract the movement and the attack, which is exactly the same functions that the monsters are going to be using. Okay, so let's just make sure I just want to double check. I'm going to put this here so that they do 2 attacks. I just want to make sure both attacks subtract points as well. Okay, and now here we go. We've got a logic problem. Let's see, which actor... So we move to the new orc. So let's see. Let's look at our game board. Who's our current actor? Actor. Current actor. Here we go. It's the orc. This guy right here. Okay. So let's look at him. He has 2 action points. Okay. And he is not executing his logic. Okay. So we need to go back and double check into our activate to game board. I think it was update active monsters run logic. Okay, so we're calling run logic. Monster decision engine. Where is it? Here we go. Run logic. Let's put this in here. Let's do a print. I'm just going to do a print error for right now. Monster, whoops, monster logic running. Okay, so let's just make sure that that is happening. Move down here, boom, and we're on to the priest's turn, barbarian's turn. Okay, so we are getting monster logic is running. And then we're trying to call melee attack. And it's not actually... Oh, did we ever... We connected up the signal, right? Active. Where is... Game board. Update active. If current actor is in group monsters, run the logic. Attack requested connect. Target selected. Okay, so we did not call? Did we not call a... Where's our melee attack? Here we go. So we got down through here. Melee attacking. Target. Okay, is null. For player, we go through all the players. Target player. If there's a target. Okay, so if there's not a target, we're still returning true. Maybe we should return false? What did we mess up here? Why is it not... It seems like it works if the attack is not on the first action. So like right here, that's the first action, so it's failing. But if we get someone else, he moves and then attack, it works. So it's only failing if it's the first action of the monster. Okay, so we've got this. This could be a little interesting. Just make sure that. Okay. So we're sending that. We're waiting. Monster complete. So this worked. Okay. So again, we're doing melee attacking. Let's see. Did we subtract? Let's see. Who is this guy? 2D. There we go. Let's take a look at him. He has not spent any action points yet. Okay. So melee attacking. So we've done this, I believe. Let's do a print here just so we can see. Because before, when they did the monster attacking, it told us who the target was. So let's just do a print target here. Okay. And let's see. Okay, so it is targeting the wizard. Okay, so we do have a target. So if the target, we're going to do a monster attack requested, and then it's just sitting here waiting for the action complete. Okay, so we are not signaling the action. Well, we're not even starting the attack. So we've got the attack requested. Didn't we connect to that in the game board? I thought we did. Yeah. Connected. Go to target selected. Target selected. Targeted. We did not get there. So did we not connect to that signal? Is that what the problem is? Did we? Oh, you know what it probably is? It's because when we go here, we update active. This is all happening. We should put this before run logic. I think that's our problem. Because we're connecting to the signal after run logic has already processed the signal. I think. Let's verify that. Okay, so we'll just end turn. Oops. I gotta switch back over to my input. Here we go. There we go. Yep. Okay. Okay. And then it does that. So that works. This, oh, you know what? This probably also needs to be put before the run logic as well. Okay, let's make sure when they start their turns. So if they move and attack, it seems to be working fine. So let's just see what happens if they start their turns right next to us. Attack. And it's not advancing to the next one. Okay. Okay, so we'll go back into our decision engine here. So we execute the attack. We await. We await the execute. And then we have a timeout. With that, I mean, we're not getting there. We're still waiting for the execute step. So if we go back to melee, we are awaiting the action complete. That should be in our targeted, I think. Targeted. Turn manager action complete. Emit for the, okay, so this is emitting the turn manager action completed for the current actor. And we're waiting on melee. We're waiting for the monster action complete. So if we do turn manager and we have Signal here, action. Action completed. Okay, we're not emitting a signal. Okay, so what we're listening for is a signal that doesn't exist. Because on the monster, we have this, but we don't have a action completed. Oh, we do. We have it right. Oh, it's because it's on the actor. Actor, action complete. Oh, did I do the wrong signal? Let's go back to engine. No, it's melee. Melee. No, it's action complete. Okay, I got the right thing. So that signal does exist. Why are we not signaling it though? Okay. Why are we? It's working. So it works if we do move and attack. It works if we attack. But it doesn't work if we attack twice. Was that it? Hold on. Now I'm second guessing myself here. Just move these guys out of the way just to try to validate some stuff here. Okay. So if we just move them over to here. Okay, so now they're going to have to move and attack. Move, attack, advances turn. Move, attack, advances turn. Okay. We're going to fix that today, the overlap. Move, attack, advance turn. Move, attack, advance turn. Okay. So that's fine. And then if we leave them be, we attack, but we don't move to the next step. Okay. So, but we did spend the action point because we went from 2 to 1, but we're not advancing the while loop. So the melee attack is not finishing this execute loop when it's doing it a second time. That doesn't make sense. Let's do a print. Let's see if it's getting into the second loop of the while loop here. Print iteration. There we go. Print iterations. Let's do a current loop iteration. So we can do it this way, plus string value of that. Okay. So let's see if we're getting into the second iteration of the while loop. Okay. Current iteration 1. Yeah, so we're not getting into this. We're subtracting the AP point, but we're not getting into the second iteration of the while loop. Okay, so let's see why that is. Let me just double check something here. Okay. For a second there, I thought that I forgot to unmute myself again. Okay, so we go through this, Let's just make sure current loop iteration ended. Okay. We'll just do that. Okay, let's try it one more time. So it did that, boom. Okay, so all of these we should see here, current loop iteration, targeted wizard. We never actually ended here. Current loop iteration. Oh, because we probably broke out. Either way, let's just end it here so then we can get to the next thing. Here we go. End term. Okay, so we're targeting here. Current loop iteration is 1. We never ended it. Okay. So if we break that out, So I think we're stuck on the execute step from melee. Are we doing... What are we doing here that's causing our problem? We do the attack requested, which triggers the targeting. We await the monster action complete. And I don't think we're ever getting that. Let's just add in one more print here. Print melee attack ended. Okay, let's see where we're getting to here. Yeah, so we're not getting there. So we're not getting this. We're not getting the monster action complete. But the weird thing is, it is working part of the time. So I think there's something hanging us up. What is hanging us up? Because we are here. I feel like maybe we need to change something here. I think we might be processing this too fast. I think we might need to change change some of our logic here. Go through here. We're going through, if it's players, turn off the panel. We await the combat manager attack actor. So that is happening. That seems to be in the wrong place. That should be sooner, but either way. So we're subtracting that. So that's fine. If our current actor is in group players, turn the panel visible, and then emit the turn manager action completed. Huh. Turn manager. Action completed. And all that's doing is it's just checking for this. We're not omitting that the action has been completed. How are we doing that with the player? Let's look at the player. Action complete, emit self. Deactivate. We're not calling deactivate, because that's where this action complete gets emitted. And the only reason that the other stuff is actually advancing properly is because we're saying it's 0 and we're checking it and it's ending the turn. But in the move, it is working. So let's look at move, await, movement finished, and then we call monster deactivate right here. Okay, so let's go back into the melee attack. We're still waiting for this, but it's not happening. So we don't want to call it here because we're waiting for that signal here. Maybe we do need to put that other one back to take it out of activate and put it into the spawn. Let's try that. So if we take this, let's copy this. We're just going to take this out. And let's go back into our actor spawn. Here we go. Combat manager, register actor. And then if it's in the monster, let's add in the actor attack requested. I don't think that's going to make a difference, but let's just... Oh, whoops. This should be underscore actor. Okay. Attack. Boom. Yeah, I didn't think that was going to be a... it was an idea. I didn't think it was actually going to be the... Whoops. Okay. Trying to think here. Trying to think. What am I missing? It's one of those things, you know, when I taught PC hardware, we're talking about power supplies. There's easy fails and hard fails. And an easy fail is the power supply doesn't supply power. It's dead. That's an easy fail because it's easy to troubleshoot. The hard fail is when like a rail is undervolting or something like that, and it's really hard to diagnose what's happening because that can appear as a RAM glitch. It could appear as a processor glitch. It could appear as a whole bunch of other different things. I feel like that's what I'm experiencing right here is it works all except for this one case scenario where it's not advancing. And that's because we have our other safety logic in place that the safety logic is advancing us, but the primary logic is not. So I need this signal to move forward. And because we're sharing that stuff, I know this is a daunting experience, but as a viewer, it's reassuring to know that we all pull our hair out trying to find something which could be an easy fix once we find it. Yeah, you should have been here for yesterday. I spent a half hour trying to figure out why my stuff wasn't working. I had my if statement logic reversed. So I was saying, if true, stop processing. It should have been if false, stop processing. I spent a half hour trying to find it. And that's where I'm where I am today. Okay, so let's see here. I'm just missing something here. Missing something that's simple. We go through, we target, we actually run through all of this. We get to the turn manager action completed. Should we omit? Is that going to break? If we omit a action completed on the actor, is that going to break anything? Let's figure out where action complete. Let's see where we're using it. Find. Okay. On action complete connected. On action completed. Action complete. Where are we emitting? Are we emitting it anywhere? Right here. This is the only place we're emitting it is during the deactivate for the monster. That's the only place we're using it. Oh, on the player. We're also using it here in the player deactivate. Okay. So after player attacks, where are we calling the player deactivate? Let's figure that out. Let's find where we're calling player deactivate. Here's a player. There's a deactivate. We're calling it here on movement finish. We call deactivate. This is in player. In monster, a movement finished emit. Turn completed emit. So we're calling it, that's player. Monster, move. Okay, at the end of the move, we're calling monster deactivate. But we're waiting for the movement finish signal. Okay. What? Okay, so we'll redefine the deactivate signal. It says we do all this, and then we set action complete, emit self. Action complete, emit self. So if I add that into to the melee, attack requested emit. How is the player attack getting the deactivate? Let's look through the player. Okay, so if we're a player and we call the attack action, what we call that? Select target. Buttons, attack button. Attack, actor attack. Actor attack. Let's see here. Actor attack. Sorry, people just came into the house, and probably an upset child might be very loud on stream. So, okay, actor attack. So we come in here, we check the action points, yeah. We select the target, and then we go to target selected, which is the same path that the monster's taken. So we come down here. We go through here. If they're in monsters, or sorry, if the actor's in players, we go through targeted. Okay. And then we await this. Okay, that's fine there. Then we use the turn manager action completed. That's all we're doing. There's no... Action manager. Wait a minute. Was that turn completed? What was that? Game board. Turn manager action completed. Sorry. Action completed. And then here we just check it, and then we request the end turn, and then we emit and move on. But we're never doing... Is this going to break if I put in here? Oops. Right here, if I just do actor.action complete emit. Right? Actor. Action complete. Emit. I have to emit self. Okay. Where was I just? Turn manager. That's where it was. Emit. Actor. Is that going to break other things? Yeah. Infinite recursion. Okay. So if I do this, and if I go back into the move logic, and instead of doing monster deactivate, actually, we can still call monster deactivate. That's fine. But let's go look at monster deactivate, and we just take this away. So then it does that. Okay. Move, attack. And then we have turn manager action completed. On actor, action completed. Oh, hey, here. Is this where we're unregistered actor? Did we kill a... Hold on. Did we kill an orc? Is that what happened? No. Why was this tripping? Oh, because I scrolled up to the wrong thing. Okay, so turn manager action completed here. Okay, on actor action completed, call this. This is combat manager. Call the turn manager action completed. Okay. Action completed. We admit that we. Okay, so that's not going to work. Okay. Let's go back into our monster. Let's put this back in here. I feel like we just need to add this into. So when we do the combat with the player, turn selected, we go through all this. It finishes up. We await this. Can we just do else if, oh, LF, whoops, LF, current actor dot is in group monsters monsters. Then we can just do action complete emit. We want to do current actor dot action complete dot emit. The action complete, actually, do we have? Yeah, we do have a node. Okay. What if we do it that way? Will that break things? Yeah, let's find out. Boom. Okay, moved on to the second attack. That's good. And we just stole the barbarian's turn. That's not going to work. Move, attack. And again, we just stole the priest turn. Because now we're probably double emitting. Yep. Do we need... Oh, actually, you know what? Why don't we take this and just put this under the player. So then we don't call it if it's the monster. Let's try that. Attack. Attack again. Moved. Attack. Hey, we didn't steal the turn. Well, that's a positive. That's right. Yeah, the targeting is still broken on the players, but okay. Move, attack. Okay. If we end turn, I want one of these guys to double attack. One attack, two attacks. And move on. Two attacks. Okay. Okay. So yeah, so moving that logic. Okay, so why did that? So we're only going to use turn manager action completed on the player, because then we'll just emit this from the monster. And this is only in the combat. Okay, so that should work fine. That makes sense, because the player logic and the monster logic are slightly different. So that would make sense. But we introduced some other errors. Let's just double check what we got here. Action complete. Node cannot convert argument 1 from object to object. Oh, this should be not self. This should be current actor. Okay, let's just double check this again. Let's clear this out. Just make sure that this works right. End the turn. Okay, attack. Make sure we don't get, okay, no errors. Okay, let's just double check our debugger here. On turn completed emit. Method expected 1 argument but called with 0. Okay, so turn completed. I believe we have to send in our self. Believe. Turn completed is... No, this is empty. We'll just have the node here. Okay. Okay, those are working. What did we end up here? Now we have expected 0, but called with 1. Let's see here. So the decision engine, hold on. Monster GD on turn completed, right here, on turn completed. Error column from signal turn completed to callable, game board, end turn. Method expected 0, but called with 1. Game board. I didn't think we had a turn complete. We have end turn. Request end turn. Send the current actor. Actor, turn ending, emit the actor. What are we doing here? Hold on. Turn completed, emit self. Expected 0, but we sent 1. Okay, so if we don't send anything, then where was the other one that broke? Okay, here it is. Nope, we got turn stealing again. This one. Monster on turn completed. Method expected 1 argument. So sometimes it sends it, sometimes it doesn't. What if we just send null? Okay, now we send the end turn. Let's just make sure we're not turn stealing right now. It doesn't look like we're turn stealing. It is complaining about this, but we'll want to clean that up. Hi, Bree. Okay, so we've got that. If we do a fireball, it'll kill all of them. Boom. Okay, so that works fine. Let's see if we can get some more out here just to make sure things work. There we go. We'll end the turn so they have to walk to us. Walk, walk. We're going to get that error of their end turn, which we did. Okay. So we'll have to sort this out, but at least now we don't have turn stealing. So this is working right now. So I will figure that out after. Okay, so let's move on to... I wasn't talking to you. Okay, so let's move on to... Actually, we're going to work on the movement of the monster. So let's... we'll call this right now good. So we're spending action points for the monsters for each of their actions. This is technically it's an error that we need to fix, but for some reason, sometimes we're calling it with an expected 1, sometimes we're not. So I have to go back and look to see where this signal turn completed is connected, because some of these places is not going to be in the right spots. Oops, I didn't mean to do that. I wanted to dismiss it so it doesn't keep dinging at me. Okay, so we got that. Let's add in let's move over to all this stuff. Let's close out everything except for the monster move. Monster move. Close all. There we go. Okay, so we're going to work through this. We're going to just strip all of this out because this was our old targeting. We're not going to need this anymore. Okay, so, excuse me. So the idea with the breadth first search, let me see if I can... BFS algorithm. So if we look at this, we had basically the idea of this. Let's see, open a new tab. Oh, I wanted to open the image in new tab. Open image in new tab. There we go. So basically the idea is we'll start with the target cell, the player that we're looking to attack. And then we're going to go through and we're going to check the 4 squares around them and see if any of those are available to move to. If those are all occupied and we can't get to them, then we're going to check each of those cells and the 4 cells around each of those until we find one that's viable. And the first one we find that's viable, then we're going to move to. And the reason why I did it this way versus if we go back over here and we do depth first search, and this way is a little bit different. Let's see if I can show what would be a good diagram to explain it here. Sure, we'll go with this one. There we go. Open a new tab. So on this one, basically what we can do is here's our target cell. And then what we do is we go, okay, is the square underneath them open? It's not. How about the square underneath that? Is that one open? No. How about the square underneath that? And then what you can do is you're going to have all the monsters lined up all the way back here. So they're going to be player, monster, monster behind that monster, monster behind the other monster. So we don't want them to just make a conga line waiting for their turn to get to that square next to the player. So whereas this one is, we'll fill all 4 squares around the player, and then we'll fill in the other squares after that. So that's the idea behind this. And so basically to do that, the algorithm that I'm using is we're going to track where all the occupied cells are first. And then from there, we're going to go through a queue. We're going to queue up the target cell. That's instantly probably going to fail because it's going to say, hey, there's a player there. Check all those squares around it. And then so we're going to add into a queue the 4 squares, the cardinal directions. And then we'll check those. If those are any of them are valid, the first one we check, whichever order we assign them in, the first one we find that's valid, then we're going to break out of the algorithm and say, this is going to be where we're moving to. After that, if all 4 are occupied, then it's going to go through and look at those 4 and try to see, it'll start with, the south cell. That's what we're using before. South cell are the ones we already know that the north is occupied. So we're going to keep track of all the ones we've already checked. We know that one's not valid, but let's check the left, right, and the down one and see if those are available. And again, first one we come across that's available, then we're going to move the monster to that. So it should give us a little bit more intelligent logic. So the monsters will surround the player. And then once we do that, we just go kick back into our standard. We pathfind around, use an A star, and move the character there. So, okay. So the first thing we want to do then here is, so we have this. This is our old logic. Let me see what we can do to re-update this stuff. Remove the file point. This is, we don't need this anymore because that's going to be part of our BFS. Yeah. So this is going to be our later stuff. So here, this is where we actually move the monster. So this stuff should probably stay because once we find the target cell, then we can get the point path to the cell and we can figure out, where they're allowed to move. So all this stuff should be fine. We can reuse that. But up here, how we calculate this target cell is going to be the big thing. So let's do that first. So let's set up our, let's figure out where people are first. So if we do a var occupied cells, OCCUPIED, is that right? Yeah, that sounds right. And that's going to be a dictionary because we're going to store a whole bunch of vector2i's and we're just going to make that, blank to start with. And then we also need, so we need to know for player and players, player underscore players. There we go. So, because we're sending both the monster and the players here. So for player and players, and then we can just append all those occupied cells. This is a dictionary, not an array, so it's not append. It's dictionary is index, key. That's what we use. So we're gonna refer to it as the player.current cell. Okay, and then we're just gonna set that to, we'll just say it's true because then it's occupied. So that will go through and it'll have our 4 players, and it's going to add in the coordinates to the cell is going to be our key, and then we're going to put the value true just so that it holds that. So then we can do for monster monster and get tree dot get, was it get nodes in group, get nodes in group monsters. Okay. And then we need, let's make sure we're not including ourselves. So if monster equals, oh wait, am I reusing monster? I am not. I'm sending in just monster. Here we go. So if monster equals monster, okay, then we don't want to include this. So let's say if monster does not equal monster, and then what we want to do is we want to take our occupied cell, and then we're going to do monster dot current cell. Oh, whoops, this needs to be square brackets, current cell. Okay, and then that's going to equal true. Okay. Get tree. Oh, right, because this is a logic step. This is just a resource. So we need to use something that's going to be in the tree. So let's use monster. Monster.getTree. Okay, there we go. Okay. So that will populate our dictionary, tell us where everybody is. So we know where people are on the game board. Then we want to build our queue that we're going to work through. So let's do a queue. And that's going to be we're going to use that as an array. And that's going to be an array of cells. So vector2i. Okay. And then that's going to equal, let's start with our target cell. Okay. So at first, we're going to focus on the target, the player. We already know it's going to, that's already going to be, yeah. Sorry, I was thinking to myself of like, what happens if the player's too far away? Are we still going to, no, we're still going to target the cell of the player, even if he's like 12, 18 spaces away. We're going to still target the player. But then when we get down into our logic down here, we're going to slice it down so he only goes 6 spaces or whatever his movement speed is. So the queue, that's always going to be full, but we need a place to start with. Then we also need to keep track of our visited cells, and that's going to be an array again of vector2i's. Excuse me, but that is going to be blank to start with. Right? Is that what we want to do, or do we want to use a dictionary? No, let's use a dictionary because then we can just say we can use the dot has later, I think. Yeah, let's do dictionaries. Visited is a dictionary like we're doing before for our occupied cells, because it's going to be basically the same exact thing. And then we're going to, because we already know that the target cell is going to be in there. So let's go ahead and just do this and then do true target cell, colon true. Okay. DICTIONARY. There we go. So we already know that our target cell's there and it's going to be true, so we can add that into our visited. So we know instantly, don't check this again. And the reason why we have to do that is because when we're checking the cell below and we run through, we go, oh, is the cell above us valid? And then we can just quickly go, well, we've already checked it. Skip it. Move on to the next. Okay, and then we want let's call, yeah, let's do best move cell. Okay. And then that's just going to, right now, we're going to equal to the monster cell, underscore monster. Do we want to use a separate variable for this? I'm trying to think. Monster.current cell. I think we're going to need a reference to the monster current cell. Yeah, we'll just put it here for right now. Current cell. Okay. Oh, whoops. Best cell move. This is going to be a vector 2i equals. There we go. Okay, so that's going to define our current cell. So we're going to say right now we're in our best move cell. And then as we calculate through, we're going to update this value as we find better cells. Okay, so now what we have a queue that has one cell in it right now. So let's go ahead and do a while loop. So while q, ue, and then we're going to q.size because we want to make sure if there's anything in the queue, then we want to run through it. If there's nothing in the queue, we're not going to do this. So while queue size is greater than 0, oops, that's not 0, that's a 0. We're going to do var, var current cell. And then that's going to equal the first item in our queue. So we'll do, is it pop? What is it? Pop front. There we go. So we'll just take the first cell that's in our queue array, our first coordinates, vector 2i. Okay. And then we're going to say if current cell, we're going to do something real easy, does not equal the target cell, which target cell. Okay. So again, up here, you know what? Let's do, because we have target cell here. Yeah, no. I was just trying to think from my logic. I tend not to reuse variables whenever I don't have to, but there are some times where it just makes sense. Like target.current cell already exists, but we're using this for local references. I think I'm going to do the same thing, actually. You know what? Let's do that. Let's do monster cell. And then we'll just put monster.current cell here. So then we can, whoops. So then we can just call monster cell. It's just a lot easier to, same with this, monster cell. There we go. It'll just make our logic a little bit easier to follow as we go through. Okay, so if our current cell does not equal our target cell, then that means the we can't stop on top of the player that we're targeting. So if it doesn't equal our target cell, then we can say, then we need to check it. We need to see if it's a valid move point. Right? Because this is our target cell. So this is where we're going. This is the target we're trying to get to. So if our current cell that we're checking does not equal this, or should we just do right now if it equals that, and then we can just move on? I have to come back to that one. Let's just move on with this right now. We also need our, we need the A star stuff. So we need a var, we need the var, we need a region, and we also need the grid. And I think, if I remember right, we have monster dot, oops, too many R's in grid. Monster, I think we have a grid. What do we have in monster? We have monster. Oops, double click. There we go. Monster. Oh, actually, you know what? It's probably in the base class of actor. We have movement, grid. There we go. Yeah, so it's an actor grid. Okay, so if we go here, grid is monster.grid. Okay, and then region is going to be our grid.region, region. This is for our A star stuff, so we can go through that. Okay, so we have the grid, we have the region. So what we want to say is if region, region dot, and then what we want to do is we want to make sure that this is a valid cell. So let's say has point. Okay, so if the region has point, oh, you know, we should probably define this. This is a grid is a star grid 2D, and then the region is let's see, what type is the region? Is it a star region? Can't remember now. Region. I thought there's a I can't remember the type now off the top of my head. I'll just do colon equals. That'll work. For region, okay, dot, there we go, has point. There we go. Okay. And then we need to set the point. So we need to check the, we're checking the current cell, right? Because we're not, target cell is not going to change. That's going to be where we're trying to end up. So let's focus on the current one that we're iterating through. So if we use current cell, oh wait, did I double use the thing? No, I didn't. Okay. So if it has a point in the current cell, okay, and it's not in the occupied cell dot has current cell, okay. And let's also make sure that there's not a player there, and not grid dot what is it, is point solid. Here we go, and we'll say current cell. Okay, so we go through all this. If region has the point, so make sure it's in our A star. Make sure it's not occupied, and make sure it's not set as solid. Okay, so we don't want to, you know, our region might have our wall. We don't want to try to walk into a wall. Okay, so if that's good, then we need to check the path to it. So let's do a var path equals grid set. Is it set? Is it? No, not set. Get yeah, ID path, and then we're going to go from our monster cell, and then we're going to go to the target cell. Or no, we want to use current cell. Yeah, let's use current cell. We want to make sure we can get to the current cell. Okay, and then we can say if path dot size is greater than 0. So that if there is a valid path for us to get here, then we can set our best move cell equal to our current cell. Okay. And then we want to break out of the while loop. Okay. So that will go through, and that will validate our cell. You know, is our cell valid? Do we have, you know, again, going through all this stuff, is it a valid point on the A star grid to start with? Is it not occupied from our occupied dictionary? Oops, this must be underscore monster. There we go. Make sure it's not occupied, and make sure it's not a wall, you know, solid, so it is walkable. And then then check again. Let's make sure there's a path to it. If there is a path to it, then we can say that our best move equals that current cell. So, and then this, I forget what the path is. I think it's like we're just going to do colon equals, but I believe it's an array of vector 2i, and we can just do array. There we go. Boom. Okay. So then, okay, so we've got that. But now what happens if the cell we just checked is not valid, which it won't be for the very first one because it's our target cell. We know the player exists there. So we can't do that. So now what we need to do is we need to actually build or find our neighbors and then figure out which neighbor we need to check. So let's go through, let's do for a, let's call it direction in, which order do we want to search in? Vector 2i dot, and just like the vector 2i still has up, down, left, right, yada, yada, yada. Let's just go in the clockwise. So let's start with up. Then we'll do vector 2i dot down. I'm just going to copy this and make our right, down, and then left. Okay, so this is the order we're going to search in. We're going to check the cell above, check the cell to the right, check the cell down, check the cell to the left. I mean, we could probably add in some variety and just pick one of these at random and then go and then, see if that works. But this is a simple game. We'll just go that. Player picks up on the pattern. Hey, cool. Okay. So we're going to set the directions. We're going to do a neighbor, neighboring cell, NIGHBOR. Vern, what are you doing, Vern? So our neighbors are going to be, this is going to be a vector 2i. Okay, and that's going to equal our current cell plus the direction. So if it's going to be our current cell plus a vector 2i up, it's going to, move the equivalent cell values. Okay. So that will be our neighbor. And then we can just say if region dot has point. So we want to make sure it's a valid thing in the region, because remember, if we haven't added the tile yet, they can't stand in the empty gray space. So we want to put in the neighbor here. Neighbor. Okay, so we want to make sure it has the point. And we also want to make sure it's not in our visited dot has, what is it? Visited dot has, yeah, has neighbor. So we want to make sure it's not in our, we haven't already checked it. So if it's not, if it does exist and it's not visited, then we're going to look at the, do we want to just look for, I'm trying to think here. Do we want to just reuse the point solid, or oh, no, because we haven't marked the enemies or the players as solid yet. So we need to actually look at the tile data to find out if it's walkable. So let's do var tile data, and then we're going to make that equal to our monster dot dungeon tile, DUNGEON, dungeon, is it dungeon tile map? I forget how we did. Dungeon tile map set. I forget. Monster. What would we call it? Or is it an actor? Dungeon tile map. That's what we called it. Dungeon tile map. Okay. So we're going to look at the data in there, and then we're going to get the cell, cell data. And then we're going to look for the neighbor and find out, what's at that cell. Okay. This is going to be, I think this is just a string. No, this is a coordinate. I don't remember off the top of my head exactly what that get cell data is. What's that return? Oops, Control Z. Get cell data. What does that return? We're gonna have to jump over here and look at Godot. Get cell data. Oh, let's see here. Nope, that's I want the documentation. I don't want that. Godot docs, here we go. Control F, boom. Don't we have get cell data? There, we'll put it over here. Get cell data. Why is this so big? Here we go. That didn't help any. Let's try this again. Tile data. Oh, maybe, yeah, tile data properties. Oh, I don't remember. Is it maybe under tile map? Let's try tile map. Tile map properties. Okay. We're looking for get cell tile data. Here we go. This is going to return turns the tile data object. Okay, so if this is colon tile data. Okay, so then that's going to return the tile data. Okay. Yeah, I'm trying my best. I was guilty for so long of just doing random, not doing type safety. And so I'm trying to be as good as I can be about my type safety. Okay. So we got that. Let's find out if it's walkable. Walkable. That's just going to be a bool because we're just going to find out if it's yes or no. And that's going to equal the tile data and tile data dot get custom. Is it custom? Yeah, custom data. And we're going to look for walkable because we tagged our stuff with that. Equals true. Okay. So this is going to say if it's walkable, and then we're going to say if walkable. Then what we can do here is we can add it to the visited neighbor, NEIGHBOR, visited neighbor, and then we're going to equal to true. Okay. And then we're going to add this to the queue. We're going to push back. We're going to add it to the end, and we're going to add the neighbor. Okay. NEIGHBOR. There we go. Okay. Okay. So that should add this to the neighbor. And then we're going to go through here. We're going to do the queue. We're going to break through. We're going to go through and find the best move cell. And hopefully one of these neighbors will second guessing myself here. Because will this, as soon as I pop this, is that going to make this 0? Second guessing myself. That's all. Okay. But yeah, so then we got the neighbors. We got that defined. So if it's not the original target cell, we're going to add in the 4 neighbors. Well, we're going to check the 4 neighbors. And if they're valid, then we're going to add it in. Okay. And then up here is where we check to see if there's something standing in those cells. Okay, so that should give us our best cell. So we do this, and our best cell, we're going to put this here. That's going to be our best cell. We don't need this stuff. Get rid of all that. Our move points are going to get point path from our current cell to the best move cell. Okay. We're going to pop the back. Why did we pop back before? Oh, because we don't want to move. Oh, we don't need this anymore. Because this was, we don't want to move on to the player. So we don't need that anymore because now our best move cell is going to be already determined. So we don't need to pop that out. We activate the monster so he starts moving. Here's his move points. I don't really need to print that. Limit to 6 cell or whatever his movement is. So we sliced it to the monster movement. Target cell, start move, monster deactivate. Okay, I think let's cross our fingers here. Cross, cross, cross. I think this is going to work. It's okay. There's something else I am missing, but I want to test this first. I just want to double check. Sorry. Need to double check one thing real quick. Oh, okay. Okay. Sorry. People are coming and going on the security camera. I wanted to make sure that my wife has an appointment, so I just wanted to make sure that my son has got somebody paying attention to him. So, okay, perfect. Perfect. Okay. Okay, so right now, what is happening is we should be able to pick a perfect cell of where we want to go. The problem I don't have implemented yet is we're going to be able to walk through monster cells. We're going to be able to walk through player cells to get to our final cell. We'll be able to go back and reslice that type of stuff in a second. We'll just kind of like we do with the players. What we're gonna set as active or solid and not solid. Okay, so monster move. I think this should be good. Yeah, let's try this. So the monster should not stop. Oh, I used the wrong variable here somewhere. Turn the assign vector 2i to a type of array vector 2i. Q. Oh, we need like that, I think. There we go. Okay, so let's see here. We're gonna end our move. We're gonna expand this. We're gonna move him up to here. We're gonna just try to get these orcs to move out of the way. We're gonna end that turn. Okay, we're gonna move him up to here. Okay, this will force them to move. Okay, non-existent function get cell data. Okay, I thought I did that right. Where is this? Get cell data. Dungeon tile map dot. What was it then? Get cell. Oh, I think it's tile data. Let's try that again. Okay, let's see here. Let's move you up and out of the way. Boom. Okay, so he didn't step on anybody, so that's good. He went around to another place. Remember, we checked first up, and then we checked. Ah, shoot. Why didn't we? Why didn't we spot that other orc? Okay, those had nothing to do with it. Why didn't we spot that second orc when we checked the occupied square? Where are we? Oh, wait. Did we? So here's our execute. We go through, here's our occupied. For every monster that's not myself, occupied cell monster equals true. Oh, wait a minute. Because I'm adding the wrong thing here. I don't want to use monster cell. I want to use this monster. Monster.current cell. Okay, so that's going to add in the other orcs. Okay, so let's try this again. End return. Boom. Okay. Yep, I'll go up above. The next one should go over here. Yep, and then the next one should move over here. Yay! Okay, so now we have intelligent moving ones. Now what we need to do is we need to set up so they don't walk through the players. Okay, so that one's actually pretty easy because we're already doing that in the player move. I think it is player. Where did we do move points? We do nope. Player. Here we go. Player monster tree. Where do we set? We loop through. Here we go. For player and get tree players. Is occupied equals true. Is occupied equals true. Okay. This is just checking. This is saying if occupied. No, where's our move? Move start. Don't we have a move start actor maybe? Actor start move. Here we go. Move points is empty. Nope. We have a way. We did it here somewhere where we set solid. Oh, is it in the game board? Let's check the game board. Actor move. Nope, that's not it. Where I thought it was in the player. Oh, right here. For monster and get tree, set that. Okay. This is how we turn it off. This is how we make them solid. Okay, so if we do this, actually, do we have this in monster? So I think we already have activate. So let's go double check monster. We have activate. Players, set for true. Deactivate. Set to false. Okay, so we already have that. So we're already doing that. Why are we not? Okay, so when we do a player, we do process input true. And then in the physics for the player, oh, it's not in the physics, it's in the actor physics. Here we go. We go through all the points. We say moving is, we start move. Okay. So in the monster, why does it not? Oh, because we don't do the start move here in the monster. Whereas in the player, on activate, oh no, we don't do a start move there either. But we do have an on move finished. We have that in monster as well, right? Yeah. Okay. So why move? Here we go. Why do we not have? So we already have them set as solid. So when we're calculating this, right here, they should already be marked as solid. Well, let's try to just put it in anyway. So let's do for cell in occupied cells. We're going to do it this way. We're going to do grid, grid.set, what's it called? Set point solid. Okay. And then we're going to pass in the cell, and then we're going to say true, mark it. Oh, because we did this here. Let's pull these out of the while loop because we're going to need these outside the while loop. So let's put those here. There we go. Okay. Yep, so there we go. So we can put that there. Let's do the, do we already do a path calculation? I don't see it. var path. Let's do grid.set. Not set. Get. No, we already did that. Let's do. So that's already okay. So that will set it solid. We don't need to do this because we're already doing this down here. Wait a minute. Activate. We don't want to activate them until after we have the move points, right? Yeah. Maybe this is why. Do all that. Do all that. We start move and then activate. How do we do this in the player? Player. So we do all this stuff. We move points, target cell. Deactivate movement, finish, deactivate. Yeah, how do we do the move in the player? Actor, start move. Move points is empty, return. If not, play that. Okay, that's fine. Is it game board? Actor move? Actor move. And then we just call activate. Okay, so player activate. We just, so on activate, we do this. And then we set process input to true. A monster, on activate, we do this. Oh, we never set the, yeah, we never set the what's it called? Physics process to true, which we're doing here in the player. Oh, this is process input. We don't want process input. So we don't want activate because activate is how we turn on the targeting method for a move. So we don't want that. So yeah, we start the move. Let's go monster, start move, actor, start move. Here we go. So this is where we turn on the physics process. If the move points are empty, we return. Otherwise, move forward. Okay. So here we start the move. We activate them. Oh, we don't need this start move then because activate starts move, right? Monster, activate. Oh, it does not start move. Okay. So we don't need. We still need the start move, but we need to do after activate. Let's go back here. Activate. This is where we set those grid. We don't need this anymore because we're doing that in the move. We're setting them solid right here. So we don't need to call activate then. Because do we do on player? I think we do. We don't do super either. We just do set them to solid. Okay. Move. Start move. Yeah, I don't think we need activate. Let's just try that. Okay, so now why are you attacking your friend? Okay, so I did something wrong here. Oh boy, yeah, look, we're in a bad spot now. Yeah, double attack the wizard. Then the other guy should move. Move. Okay, he double moved. Okay. No, let's leave that in there because something funky happened there. Okay, so we do this, do this. Okay. And right now, because the way I have it, I don't have ranged on my attacks yet. So it's already saying the move is invalid because I'm already in my best cell. So I can't move. So I'm just going to attack. Okay. So that's what's happening there. Okay. So now if we do, say move this guy up to here, I have no idea why that just happened. Move points normalized. move points.size. Oh, I think we just need a double check in this. If move points equals 0, we should probably just kick out of it. So size is 1. Let's try this again. Nope. Okay, we move up and then attack. Okay. Why are you determining that that's the best? So why is that happening now? Okay, let's go back here. Let's do... So if we get rid of this, we just kind of keep where we're going. Wait, what else did we do here? Let's... We did some shuffling around. That can stay. We'll move that back in a second. Okay. So we save this. We're going to pull this stuff out. I'm going to put this up here. Okay. So now we're back to... They should be able to walk through, because when I did that, it was breaking things. Okay. But we're still overlapping because the occupied cells aren't checking properly. Okay. So if we go back here, so we're saying stuff is a valid neighbor. And then when we go through here, current cell, if it's not, if occupied cell has, so if it's not in the occupied cells and it's not solid, then that is the best path. But why is this not? Where are we calculating this? Let's look here. Oh, I went back too far. Monster dot current. I undid too far. That's why. Okay, this should not overlap. It'll allow us to pass through, but it should not overlap. Okay. Yep, we're not overlapping. So even though this is the closest, let's see where he moved. If I move the rogue out of the way, this guy should then move up to here. Yep, there we go. Okay, so he moved where we predicted he would move. Okay, so we're not overlapping right now. We're still having the problem of what's solid and what you should be allowed to pass through. So why are those not being solid? Are we using the grid? Where? Oh, wait. We're using the monster grid here. Why don't we use grid? We'll use the local grid, because up here, if we do the, right, because we're using local grid, monster move points, where are we? Here we go. We're going to keep references to the same grid. Okay, and then so if we do for cell and occupied cell, And then if we do the grid dot set point solid, we want to do the cell, and then we want to do true. Okay, so that should just set everything solid, right? Cell and occupied cells. We set the point solid true. Okay, and then if we're going to set it here, we're going to do the deactivate here. We're going to just set them back here. Okay, because what we're doing is we're setting the occupied cells as solid. Then after we move, we're going to go back and set those other cells as not solid anymore. Okay, let's see. They should not walk through any other person. So monster or friendly. So like right now we can move through friendlies, but they can't. So if I move to, where would be a good way to spot to test this? And we'll just move up here. That's fine. Okay. Okay. Okay, so that's done. That's done. We're back to our problem now. If we double move, we have that signal problem. But what we have here at least is the moving is working. So we're doing the solid cells so that we're not walking through. Oh boy. We're not supposed to be able to go through where it's not walkable. Oh. Get point path. Monster. Oh. You know what? Let's just also use this as monster cell. We'll use that as a local reference too. Let's see here. So we're going to find the best cell. We're going to go through these. So why is this allowing us to walk outside of the valid space? So this is saying there's a valid path right here. So if this is the path we're using, oh, that's ID path. That's not point path. So if we got all these here, why don't we do, you know what, let's do this. Let's cut this. Let's do some troubleshooting stuff here. Let's put this here. And then I'm gonna have to call it for the day very shortly because fun stuff. So if we do the path, we do the grid, and then what we want to do here is we want to get the point path, excuse me, and we want to go from the monster cell, and we want to go to the best move cell. Okay, so that's gonna be our path. So we set the solid tiles, we find the path, we turn off the tiles. Now we know the best cell. The move points is going to be the path, but we're going to slice the path. So let's take this out here. Let's do monster move points is going to be, we're going to take the path. We're going to slice it by the monster movement, right? That seems right. Then we're going to take the move points. We're going to map them to the grid cell size so that we go to the right place here. And then monster, we don't need target cell, right? Are we using target cell and actor in our physics? We're not using target cell. Start move. Physics, current, slice, 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 slice. Yeah, we're not using the target cell, so I don't think we need that. Because the target cell is only for when we execute. Our target cell is where our target is. Okay, so we don't need to worry about that. So we'll have our move points. Then if we have our move points, we start our move. Okay. So that's here. We await the move finish signal, and then we deactivate the monster. Okay, let's try this. Let's cross fingers, make sure everything works fine. Hopefully we don't walk out of bounds again. Okay. End turn. Okay. I'm just trying to think here because this, whoever moves next is going to move to this cell because that's going to be the closest target. Once this is occupied, so this will be occupied, this will be occupied, this will be occupied, this will be occupied. We then should go to the probably this one, and then we'll go to this one. So that will probably be the next target cell. Yeah, let's try that. But that is going to depend upon who moves next. So let's see. Okay, so that one, just as I predicted. The next one I think is going to be up here. Yep. Okay. And then the turn's over. We still get that bug. Okay. But we do have him moving to the right cell. So that is working. We do have the end turn not ending properly, but that comes back to the problem we had earlier. So, okay. So we've got today, I get the breadth first searching working. So that's good. We've got that in place. Let's go back over here. Look at my little checklist here. Yes, we have that. We have, oh, yep. Give me 1 second here. Okay. Let's see. We got the monster move. We have I had a note here, and I don't know if I really want to do it or not, but in the monster move, where we do the beginning here, this player distance, we're using the A star here. We could simplify it and just do X plus Y to figure out who's closest. I think I'm going to leave it as A star just because then that's where our pathfinding is based off. So I think that makes the most sense. But it was a question mark of, do I want to simplify that? So we found all the cells that are populated. We found our target. We searched from the target outwards. We made them solid. We computed the path and we moved. We do have that other problem with the end turn, but we'll go back and solve that afterwards. Let's see here. We fixed the stealing turns problem. I think we fixed the call down. Where is the melee? Melee. Yeah, we fixed the call down signal up because remember this was calling the grandparent before, so we fixed that. And wow, I can't read my own handwriting. Loop something. Loop safety. That's what I wrote. It looked like an S or an F. Safety. There we go. We added in the loop safety there. Okay. So I think we have got pretty much everything in place. We have that one bug of the monster double move not ending the turn. So let's go ahead and add that over here. We're going to just hit stop on this. add a card, monster double move bug, and we'll just add it in here. Moving 2x doesn't end turn. Okay, so we'll add that in. That's in our bugs column. Save that. Monster stack up. Guess what? We finished that. That is done. Okay, so we can. That is in the done. Or I'll leave it in the bugs because that's done. Turn manager doesn't wait. We did fix that today too. So that now it waits. We added in BFS. So that is done. Okay. So we have the targeting system and the buff system left to do. And for some reason, I don't know why up there, I have no video anymore. Let me figure this out. 1 second. What happened to the video? I have a feeling that the camera overheated or something. Let's see here. There it goes. Just had to quickly reboot the camera. Thankfully, the audio doesn't go through the camera. So, okay. So that's there. That's there. Let's take a look at our chart. See where we are. We are at. That's not right. 0501. We are at 43.6 hours. Ouch. 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 One note. Let's see how far behind we are. Let's see here. View 200%. Okay. We are, let's see here. We can't check anything else. Okay. But the nice thing is we do have that stuff. I just have the double move bug to rectify, which is going to be the same thing that we just did with the combat. So I just got to sort that out. I think it's going to be, I just have to trace through, I believe, if I come back over here. If we go back into our action complete, where is it here? Target selected, action complete. COMPLETE. Oops. So where we're connecting in the signals for the action complete, where are we? .connect. One of those where we're doing, you know what? I can just use this. Here we go. Boom. So the turn completed signal, here is expecting 0 arguments, but we called it with 1. So I just have to look to see what's connecting to this signal. We got the decision engine here, but there might be something else that's going on. So I want to double check here, because on turn completed, we're doing nothing, but we're calling this. And then if we remove this, then we get that other bug. So I need to double check to see what's listening to this. And then we can go from there. So I think with that, I'm pretty certain we're in a good place. We still got to build the targeting state machine. I was really hoping to have that all done by the end of the day today, but we did not get there. The buff system is going to be pretty straightforward, so we got to do that. Yeah. Are we going to hit our 60 hour milestone lock-in? I don't know, because I was hoping to have at hour 50 a playtest ready to go. We're 40, what were we at again? 43.6. So we are 6.5 hours from that playtest milestone. We're not there. I'm hoping we do have some padding. So I'm hoping we'll still be able to hit that 100 milestone mark as expected, because there's definitely some padding at the end there, but we've got to we still got to add in a whole bunch of stuff. We still got to add in items. We still got to add in the UI. We still got to add in all that fun stuff. Um, so we'll get there. But I'm gonna hope. I've got some plans on this weekend, but I am 90% certain I'm gonna be able to get a weekend stream in, and in that stream I'm gonna get the targeting system and the buff system in place. So then when we come back on Thursday next week, I'll be able to hit the player abilities, finish them up, get our battle shouts going, get our extra movement, all that stuff. We'll get that done so we can close out the milestone, and then move into the fun stuff that we need to do. Where we still have to build out our monsters, but once we have the hero abilities and the buff system in place, I think the monster is going to go pretty fast because they're all going to be kind of cookie cutter of each other. We're going to build out the base classes, and then it's just adjusting their stats. We've got a melee, we've got a ranged, we've got a brute, and a can't remember what the other one is, but we've basically got 4 monsters, and then we just make them beefier as they get higher. So, yeah, I think we got everything. I'm just glad I got through BFS today. The bug we have is not BFS related. The bug we have is my own turn logic related, back from the refactor. So refactor set us back about 4 hours. But I think in the long run, that 4-hour decision is going to save us a whole bunch of time that we would have lost debugging with the spaghetti code that we were building. So, excuse me. Throat's starting to get a little sore. It's time for me to get some lunch. Yeah, I think with that, we're going to call it a day. And I look forward to having the stream this weekend. Probably Sunday, sometime during the day. Sunday is where I'm going to shoot for. Maybe some during the day, Saturday night. I've got plans. Definitely not then, but we'll see how things work out. But until then, have a good one. And if you like what you see, subscribe and pay attention for when I post for the next stream. But every Thursday and Friday at 10 a.m. Eastern, I will be streaming my builds. So with that, have a good day. Have a good weekend.